Hello everyone and welcome back to another video on this channel. On calculus, today we will be covering some more differentiation rules, more specifically the rules for multiplication and division. So here I have the one for multiplication called the product rule, the multiplication of two functions. And then over here I have the quotient rule for when you're dividing two functions. So essentially f of x, the function that we're trying to derive, consists of two smaller functions, u and v. And in one case we're multiplying them, in the other we're dividing one by the other. So an example of the product rule could be, for example, 2x plus 3 times 5x minus 7. We can identify two smaller functions, maybe these two, and instead of expanding this out, which would also work, and then we just get a normal looking polynomial, we can find the derivative of each of these two functions and then apply the product rule, for example. Now, as for the quotient rule, you would use it if you have, we can take the same example, just when it's division. So imagine that we're dividing 2x plus 3 by 5x plus 7. Here again, you can just use the quotient rule, or you could also do synthetic or polynomial division and then differentiate term by term. Anyways, the product rule is pretty easy to remember, I think, and in any case you have it saved in the formula booklet. So it's just one of the functions times the derivative of the other one plus the derivative of the first one times the other function. Okay, so we have two terms, and in each of the terms you have one where it's just the function that was given multiplied by the derivative of the other one. So you might have to compute these two derivatives either in your head or do a small calculation before actually applying the product rule. Now, as for the quotient rule, it's a bit more complicated. On the numerator we have something similar to the product rule, but with a minus sign, so don't forget that. And a minus b isn't necessarily the same thing as b minus a. Okay, it's not necessarily the same thing, so you can't just switch these two around. So you have to pay attention to the order, unlike in the product rule when you can just switch these two terms around and it would just be the same thing. And then remember, you're dividing by the derivative of the denominator squared, so don't forget this square either. And anyway, both of these formulas are in the formula booklet. This one's a bit tough to remember, but it could save you some time. And as for the product rule, I really would recommend remembering it, since it's not that hard to remember and it could save you a lot of time. Now, for this video, I haven't prepared any examples because the application of these rules is pretty straightforward. And there are plenty of examples in the book and online. So I decided that for this video, I'll just show an interesting sort of proof, reason for why this is the formula for the derivative of a ratio, of a division. Because it's interesting how the denominator is so similar to the how the numerator is so similar to the derivative of a multiplication, and I thought I'd just show how we get to this result and why it's actually so similar. So you don't, of course, need to know this for any test. probably. It's just if anyone's interested. Okay, so I'm going to start out by writing the definition of our main function, which is f of x. F of x is the function that we're trying to differentiate, and I'm going to write it out as u of x over v of x. And I'm actually going to start on a new page. So this is allowed. This is just how we define the function. It's a ratio of two smaller functions, okay? So I'm not doing anything here yet. I'm just copying the definition of the function. And now I'm going to multiply both sides by v of x. And the reason I do this is because, sorry, this is v, because then we're just going to get multiplications, and those are easier to work with and differentiate and everything. So on the left-hand side, I'm going to get f of x times v of x. And on the right-hand side, I'm just going to get u of x. Since I'm multiplying both sides by v of x, and the v of x's on the right side cancel out. Okay, so now that I've transferred this v of x on the left side, I can now actually just take the derivative of both sides. And the equality will still remain true because, well, if this function is the same as that one, then its derivative will also be the same as the derivative of this one, because you're deriving the same thing. Okay, it's not a very formal proof, but I won't get into that. So I'm actually just taking the derivative of both sides, which you are allowed to do. Now, on the left side, well, we have a product. So to take the derivative of this whole thing, we just need to apply the product rule. So I'm going to write it out. It's f of x times v dashed of x plus f dashed of x times v of x. Now that was the left side, and we also need to take the derivative of the right side. The derivative of u of x is, of course, just u dashed of x. Okay, now you might already be thinking of just isolating f dashed of x, since that's what we're looking for. We're looking for the derivative of f, since that's our main function. That's the ratio. The ratio is just f. And what would the derivative be? Well, we can just transfer everything else to the right side, right? And that is what we'll do. But first, I'm going to rewrite this f of x as u of x over v of x. And the reason for that is because when we get an expression for f dash, the derivative, I don't want any f's in there. I just want it in terms of u and v. Okay, so I'm just going to replace now f of x by u of x over v of x, and now we're multiplying by v dashed of x. So let me write that up here, v dashed of x, and I'll extend this. Okay, so v of x on the denominator, and now I am just copying this term out. V of x equals u dashed of x. So from here to here, I haven't actually done anything to both sides. I've just rewritten f of x. And now, of course, we're trying to isolate f dashed of x. So all I have to do is subtract this term, and then we'll be almost there. So I'm going to have f dashed of x times v of x equals u dashed of x minus this whole thing. So that would be u of x times v dashed of x over v of x. And I'm going to move this a little to the right, as well as the minus, because now this u dashed of x, I'm going to rewrite as u dashed of x times v of x over v of x. So essentially I'm amplifying by v of x. And of course this is correct, the equality, because if you just cancel out the v of x's, u dashed of x is equal to u dashed of x. So I'm going to substitute u dashed of x by this expression. And the reason I'm doing this is to get this common denominator so that I can merge the fraction